Hello, welcome back to my YouTube channel. This is Sir DL and welcome to the Aliens Vlog. By the way, maraming salamat po sa lahat po ng mga sumusuporta, sa lahat po ng mga nanonood sa aking YouTube channel, sa mga video tutorials ko po, sa mga videos na ina-upload ko po sa YouTube. Maraming salamat po everyone. You keep on subscribing, you keep on sharing the videos. I hope these are of big help. May the Lord bless you. For today, we will be having another tutorials and it's all about the laws of exponent, and I know you are excited. Let's go! I know all of you are excited to learn this day. Let's start our tutorial about the laws of exponents. Before we start, let's try to state the objectives of this study. Number 1, discuss laws of exponents. Number 2, identify the different laws of exponents. Number 3, solve the following laws of exponents. And number 4, explain the importance of laws of exponents. Before we start, I would like to start with this Bible verse. It says here, delight yourself in the Lord and He will give you the desires of your heart. Again, delight yourself in the Lord and He will give you the desires of your heart. Sa Tagalog, sa Diyos mo hanapin ang iyong kaligayahan at ang pangarap mo'y kakamtan. Let's start. What is exponent? The exponent of a number says how many times you use that number in a multiplication. For example, if you have 3 raised to 2, that means you need to multiply 3 2 times by itself. That's why 3 raised to 2 is equal to 9. Let's try to discuss the first law of exponent. Number 1, the multiplication rule. What is multiplication rule? When multiplying two powers that have the same base, just add the exponents. Again, when multiplying two powers that have the same base, we just simply add the exponents. For example, a raised to x multiplied by a raised to y is equal to a raised to x plus y. Again, a raised to x multiplied by a raised to y is equal to a raised to x plus y. Just simply add the exponent if we have the same base. For example, we have 2 raised to 3 multiplied by 2 raised to 2. What is our premise? If we have the same base, if we are multiplying two powers that have the same base, we will be adding the exponent. So, that is 3 plus 2. 3 plus 2. 2 raised to 3 plus 2. What is 2? 3 plus 2, that is 5. 2 raised to 5. What is 2 raised to 5? That is 2 times 2 times 2 times 2 times 2, and that is 32. 2 times 2 is 4 times 2, 8 times 2, 16, and times 2, 32. Another example, 3 raised to 1 multiplied by 3 raised to 3. What is our rule? When multiplying two powers that have the same base, just add the exponents. We have 3 raised to 1 and 3 raised to 3. We will just be adding 1 plus 3. That is 3 raised to 1 plus 3. That is 3 raised to 1 plus 3. What is 1 plus 3? That is 4. That's why it becomes 3 raised to 4. Then what is 3 raised to 4? 3 times 3 times 3 times 3. That is 81. 3 times 3, that is 9. Multiplied by 3, 27. Multiplied by 3, 81. Another example, 4 raised to 1 multiplied by 4 raised to 2. Our rule is, when multiplying two powers that had the same base, just add the exponent. So, 1 plus 2, that is 4 raised to 1 plus 2. That is 4 raised to 3 because 1 plus 2 is 3. What is 4 raised to 3? 4 times 4 times 4, that is? Very good, 64. 4 times 4, 16 times 4, 64. That is multiplication rule. When multiplying two powers that have the same base, just simply add the exponents. I hope you got it. I hope you followed. Next rule, the quotient rule. What is quotient rule? In dividing same base, just simply subtract the exponents. Again, in dividing same base, just simply subtract the exponents. A while ago, when multiplying, we will be adding the exponent. On quotient rule, we will be subtracting the exponents. For example, a raised to x divided by a raised to y is equal to a raised to x minus y because we will be subtracting the exponents. Again, a raised to x divided by a raised to y is equal to a raised to x minus y. In dividing same base, just simply subtract the exponents. Example, 6 raised to 5 divided by 6 raised to 3. What is our rule? In dividing same base, just simply subtract the exponents. 5, what is 5 minus 3? That is 2. That's why 6 raised to 5 minus 3, that is 2. What is 6 raised to 2? 6 raised to 2 is 6 times 6. That is 36. Very good. The next one, 5 raised to 7 divided by 5 raised to 4 is equal to, we will be subtracting the exponent because we had the same base. 7 minus 4, that is 5 raised to 7 minus 4. What is 7 minus 4? That is 3. 5 raised to 3. What is 5 raised to 3? 5 times 5 times 5, that is 125. I hope you got it. Very good. Next. 9 raised to 6 divided by 9 raised to 2 is equal to, again, in dividing same base, we have the same base, 9 and 9. Just simply subtract the exponent. 6 minus 2, that is 9 raised to 6 minus 2. What's next? What is 6 minus 2? That is 4. Very good. Now, what is 9 raised to 4? 9 times 9 times 9 times 9. That is 6,650. What? No, 6,561 is the correct answer. That is 9 times 9 times 9 times 9. Again, for quotient rule, in dividing same base, just simply subtract the exponents. Moving on the next rule, that is power of a power rule. It says here, when raising a power to a power, just simply multiply the exponent. Again, when raising a power to a power, just simply multiply the exponent. Based on the given example, the quantity of a raised to x raised to y, because we have a power of a power to a power. So that means we will be multiplying x and y. That's why it will become a raised to x multiplied by y. Let's try to have an example. 2, the quantity of 2 raised to 2 squared, we will be multiplying the power to a power. 2 times 2, that is 2 raised to 4. 2 times 2, that is 4. What is 2 raised to 4? 2 times 2 times 2 times 2, that is 2 times 2, 4 times 2, 8 times 2, 16. That is power of a power. Next, the quantity of 3 squared raised to 3. The quantity of 3 squared raised to 3. Our rule is, when raising a power to a power, we just simply multiply the exponent. So 2 multiplied by 3, that is 3 raised to 6. 2 multiplied by 3, that is 3 raised to 6. What is 3 raised to 6? 3 multiplied by 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 3. 3 times 3 is 9, times 3, 27, times 3, 81, times 3, 243, times 3, 729. That's why the answer for the quantity of 3 squared raised to 3 is 729. The next one, the quantity of 4 cubed raised to cube or raised to 3. We will be multiplying the exponent because we will be raising a power to a power. So that will become 3 multiplied by 3, that is 4 raised to 9. What is 4 raised to 9? That is, you will be multiplying 4 by itself 9 times. So the answer will be 262,144. Again, 262,144. That is our rule for power of a power rule. When raising a power to a power, just simply multiply the exponent. I hope you understood. Number 4, power of a product rule. The power of a product rule, when a product is raised to a power, just simply distribute the exponent to all terms inside the product or in the product. When a product is raised to a power, just simply distribute the exponents to all terms in the product. Let's try to have an example. The quantity of AB raised to X. So we have product inside the quantity. That's why we will be distributing X to A and X to B. That's why it will become the quantity of AB raised to X is equal to AX, or A raised to X, B multiplied by B raised to X. Let's try to have an example. The quantity of 2X raised to 2. So we will be distributing the exponent to 2 and X. That's why it will be like this. 2 squared multiplied by X squared. What will be the answer? What is 2 times 2? That is 4. Then X squared, just copy. 4X squared. So that is power of a product rule. When a product is raised to a power, just simply distribute the exponent to all terms in the product. Another example, we have the quantity of X squared Y cubed raised to cube. Since we have power of a product, we will be distributing 3 to this part, to the first term and the other term. So it will become, so X squared, that is 2 multiplied by 3, then 3 multiplied by 3, and the final answer will be 2 multiplied by 3, 6. X raised to 6, 3 multiplied by 3, 9. Y raised to 9. So the answer for the quantity of X squared multiplied by Y cubed raised to 3 is equal to X6, X raised to 6, and Y raised to 9. The other one, the quantity of 4A cubed raised to cube. The quantity of 4A cubed raised to cube. So that means we will be distributing this number or this exponent to 4 and to A cubed. That will be 4 raised to 3, then the quantity of A cubed raised to 3. So what is 4 raised to 3? 4 times 4 times 4, that is 64. Very good. What is 3 multiplied by 3? That is 9. That's why the answer is 64A raised to 9. 4 cubed, that is 4 times 4 times 4, 64. Then A cubed, since we have a power to a power, 3 multiplied by 3, that becomes 9. I hope you understood. That is power of a product rule. When a product is raised to a power, just simply distribute the exponent to all terms in the product. Rule number 5. Quotient of a power. When dividing with different base is raised to a power, just simply distribute the exponents to all terms. Just like what we did a while ago to the product of a power, we distribute the exponents to the product. Same thing with the quotient of a power. We will be distributing the exponent to all terms. Example, we have the quantity of A over B raised to X. That's why we will be distributing the exponent X to A and B. So the answer will become A raised to X, B raised to X. So we will be distributing the exponent to A and the exponent to B because that is a quotient of a power. Let's try to have an example. The quantity of 2 over 3 squared. We will be distributing the exponent to 2 to the numerator and to the denominator. So that will become 2 raised to 2 over 3 raised to 2 because based on the rule, we will be distributing the exponent on both numerator and denominator. What is 2 squared? 2 times 2, that is 4. Very good. 3 multiplied by 3, that is 9. So the answer will be 4 over 9. I hope you are still with me. I hope you are enjoying our discussion for today. Moving on with the next example, the quantity of X over 4 raised to 3. We will be distributing the exponent on both numerator and denominator based on the rule of the quotient of a power. So X raised to 3, 4 raised to 3. What is 4 raised to 3? That is 4 times 4 times 4, that is 4 times 4, 16. 4 times 16, that is 64. That's why the final answer will be X cubed over 64. Another one, the quantity of B over 7 raised to 4. Based on the rule, when dividing with different base is raised to a power, just simply distribute the exponents to both numerator and denominator. So it will become b raised to 4 over 7 raised to 4. What is 7 raised to 4? It is 7 times 7 times 7 times 7. The answer will be 2,401. So the quantity of b over 7 raised to 4 is equal to b raised to 4 over 2,401. So that is quotient of a power. When dividing with different bases raised to a power, just simply distribute the exponents to all terms. As simple as that. Sixth rule, 0 power. Any number raised to 0 is always equal to 1. Oh, very easy. Any number raised to 0 is always equal to 1. A raised to 0, that is 1. X raised to 0, that is 1. 4 raised to 0, that is 1. 5 raised to 0, that is 1, because that is the rule. Any number raised to 0 is always equal to 1. Let's try to prove that A raised to 0 is equal to 1 or X raised to 0 is equal to 1. Let's check this one. So we have here x squared over x squared. When we divide this, we have 1. X squared divided by x squared is equal to 1. If you will be following the rule based on quotient rule, if I'm not mistaken, so we have x raised to 2 over x raised to 2, wherein we will be subtracting the value of the exponent. So 2 minus 2, that is 0. So that means x raised to 0 is equal to 1. That is the proof that any number raised to 0 is always equal to 1. As simple as that. That is the sixth rule. Okay, the last rule for today, negative exponent. What is negative exponent? When the exponent is negative, the numerator get moved to the denominator and become positive exponents. When the exponent is negative, the numerator get moved to the denominator and become positive exponents. Example, a raised to negative 1. In order for us to have a positive exponent, we need to bring it down. So from negative, it becomes positive. So it will become 1 over a. When the exponent is negative, the numerator get moved to the denominator and become positive exponents. Let's have another example. 2 raised to negative 3. So we have a negative exponent. So we will be bringing it down. So we will be moving it down. So 1 over 2 raised to 3. So that the exponent will become positive. From numerator, it will become denominator. What is 2 raised to 3? So the answer will be 1 over 8 because 2 raised to 3 is 8. 2 times 2 times 2. Next one, 4 raised to negative 2. In order for us to make this one positive, we need to move this one to the denominator. So it will become 1 over 4 raised to 2. That means 1 over 4 raised to 2 is 1 over 16. Very good. The last example, 5 raised to negative 4. In order for us to have a positive exponent, we need to bring down the 5 negative 4 to the denominator. It will become 1 over 5 over 4. What is 5 over 4? 5 times 5 times 5 times 5. That is, very good, 1 over 625. So that is negative exponent. When the exponent is negative, the numerator get moved to the denominator and become positive exponents. That is number 7, negative exponent. We're finished with our discussion with regards to the laws of exponents. Laws of exponents are very important because this is one of the fundamental topics in mathematics. You can never understand the complicated topics unless you learn laws of exponents. By the way, I put more examples on this part in order for you to know if you really understood what we discussed today. Let's try to have an example. What is 2 raised to 4? That is 2 raised to 4. That is 16 because 2 times 2 times 2 times 2. 16. How about this one? 6 raised to negative 2. That is negative exponent rule. If we have a negative exponent, in order for it to become positive, you need to put it to the denominator. Very good. So it will become 1 over 6 raised to 2. What is 6 raised to 2? 36. Very good. 1 over 36. Another example, 5 raised to 0. What is our rule? I know you remember because that's the easiest. Very good. That is the 0 rule. Any number raised to 0 is equal to 1. Next one. That is quotient rule. That is the quantity of x over 3 raised to 2. What do we do on that part? We will be, very good, we will be distributing the value of the exponents on the numerator and the denominator. So it will become x squared over 3 raised to 2. What is 3 raised to 2? That is x raised to 9. That is x squared raised to 9. So that's the final answer. We will be distributing the exponents on both numerator and denominator. Another example, 8 raised to 4 divided by 8 raised to 2. So we have the same base. What do we do on this part? Division rule. So that means we will be, very good, subtracting the exponent. So 4 minus 2, that is 8 raised to 4 minus 2, that is 8 raised to 2. Then 8 raised to 2 is equal to 64 because 8 times 8 is 64. The next example, 3 squared multiplied by 3 squared, that is product rule. So in terms of product rule, if you have the same base, we just simply, very good, we just simply add the exponent. That's why 2 plus 2, that is 3 raised to 2 plus 2. What is 2 plus 2? 4. What is 3 raised to 4? 3 times 3 times 3 times 3, that is 81. The next one, the quantity of x squared y raised to 2. So on this part, we need to distribute the exponents on both terms, x squared y. So that means you will be having here 2 times 2, 4, 1 times 2 because there automatically there's y raised to 1 here. So y 1 times 2, that is 2. So we have x raised to 4 y squared. That is the final answer. Another one. What is 2 raised to negative 6? That is negative exponent rule. Do you still remember it? Oh, I'm sure of that. So that will become, we will be moving to negative 6 to the denominator in order for it to have a positive exponent. So 1 over 2 raised to 6. What is 2 raised to 6? 2 times 2 times 2 times 2 times 2 times 2. So the answer will be 1 over 64. And by the way, there are a lot of sites on Google that you can find another examples. Then you can solve it on your own, then check it because there are examples with answers. For today, let me end up with this one. Always remember that you need to be excellent of what is good and be innocent of evil. Again, be excellent of what is good and be innocent of evil. Thank you for watching, everyone. God bless you. God loves you. God cares for you. This is Sir DL. I hope you keep on subscribing. You keep on following my Facebook page. God bless you all. Thank you. To God be the glory.